Let me start again. Okay, intro. Again. Station. So hello everybody. I've had a few problems logging on here. Hopefully things have settled down now. I'll try go into the fundraising video clip.
Hello everyone, I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order Hello everyone, I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our third annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. Hopefully, as we continue to grow, We will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system, several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
Right, thank you. Hopefully the technical problems are now sorted out. We can work okay on this. So today's talk is called Using AI, that's artificial intelligence, on Einstein's relativity, and taking an example, the relativity principle. So relativity, usual, when you talk about relativity, the usual thing that is meant is Einstein's special relativity. And artificial intelligence is now more predominant on the internet, and people can use it. So I'm using artificial intelligence, which you can access quite easily on the internet, to try to clarify some of the things being said about relativity. And taking an example, looking at the relativity principle. So what I've noticed is that people say conflicting things about relativity, and I'm going to use AI, artificial intelligence, to try to sort out the mess with all these conflicting things that people say. So this Nobel Prize winner, George F. Spoot III, says, one problem to overcome was the strong prejudice of good scientists who learned the lesson of the Michelson and Morley experiment and special relativity, that there is no preferred frames of reference. There is an education job to convince them that this did not violate special relativity, but did find a frame in which the expanse of the universe looks particularly simple. So he admits that there is a preferred frame, and that many people who believe in Einstein's relativity don't think there is a preferred frame. So there's a conflict between what is believed about relativity among those who believe in relativity. And so the problem, in my view, must be they can't agree to what the principle of relativity means. They must have different views as to what it means. In one of the ways the principle is stated is to make the claim there is no preferred frame. So therefore Spoot can't interpret the principle to mean there's no preferred frame, while others do interpret it to mean that. So if you go to Wikipedia, it says, and it states the principle of relativity. In physics, the principle of relativity is the requirement that the equations describing the laws of physics have the same form in all admissible frames of reference. So I say, therefore, from that type of definition, not everybody is interpreting it to mean there is no preferred frame. Thus need to now see what AI says to see if it can clear up this confusion of people having different opinions about what the relativity is or means. So need to ask AI, does the claim that the law of physics are the same in all inertial frames this be the same as the claim that there is no preferred frame? And AI replies, yes, the claim that the laws of physics are the same in all inertial frames is essentially equivalent to the claim that there is no preferred frame of reference. AI then goes on to explanation of it. If you wanted to, you could say, well, that's it, and end the conversation there with AI, but I want to interrogate it to see precisely what that's supposed to mean. So can rephrase the question. So in rephrasing the question, the claim that the laws of physics are the same in all inertial frames is that to be taken to mean the same as the claim that there is no preferred frame, but only when talking about preferred frame in the context of inertial frames. And AI says yes. The claim that the laws of physics are the same in all inertial frames can be understood as equivalent to claim that there's no preferred frame, but only when we are specifically talking about inertial frames. And I can clarify that further by asking more questions. But the point here is to note, go back to the statement of the relativity principle is vague. It's not a very precise way of talking about things and the way it's being stated. So the claim that there's no preferred frame due to the relativity principle needs more conditions added to it to explain precisely what that's supposed to mean. So hence now the need is to try to clarify things further by asking more of AI. So the question is the claim that the laws of physics are the same in all inertial frames is to be taken to mean the same as the claim that there is no preferred frames if talking about non-inertial frames? And it says exactly, when talking about non-inertial frames, frames that are accelerating or experience force, the claim that the laws of physics are the same in all inertial frames is not the same as the claim that there is no preferred frame. So in the context of dealing with inertial frames, then there is no preferred frame. But dealing with inertial and non-inertial frames, there can be a preferred frame. So it's loose talk with how the relativity principle is being talked about is creating this confusion of no preferred frame versus having a preferred frame. AI says this: for inertial frames, the claim that the laws of physics are the same in all inertial frames is equivalent to the claim that there is no preferred inertial frame. So it's adding now the word inertial frame. So it's not just saying preferred frame, it's now saying preferred inertial frame. And it goes on to say the following: for non-inertial frames, this equivalence no longer holds. The laws of physics do not automatically take the same form in non-inertial frames. And in this context, there can be a preferred frame. namely the inertial frame from which the non-inertial frame is accelerating. Therefore, when talking about non-inertial frames, the principle that the laws of physics are the same in all frames does not apply in the same way, and the concept of a preferred frame becomes relevant again. So it's pointing out, if you're talking just in the context of inertial motion, there is no preferred frame, there's no preferred inertial frame. But if you're bringing in the context of non-inertial motion as well, then you should bring back the idea of a preferred frame. So thus, Spoot is correct if he's talking about things in the context of inertial and non-inertial frames. In that context, there's a preferred frame. And where those who say opposite to or opposed to Spoot might not be realising the difference that context means. Context of only inertial frames versus context of all types of frames changes the meaning of whether there is a preferred frame or not. So in general, I'm generalizing it to people who are talking about relativity. When people are talking about relativity, they use loose talking and don't make their statements precise enough as to what context they're talking in. So just hold on a minute, I'll call up the comments, see what's going on there. Yeah, okay. So before going further, let's look at some maths and looking at equations. So for example, let's look at this very simple equation, y equals x. When x equals 1, then y equals 1. When x equals 2, then y equals 2. When x equals 0, then y equals 0. When x equals -1, then y equals -1. And so forth. It's a very simple equation, y equals x. And you can draw this very simple graph for that equation. But now let's look at a slightly more complicated equation. If you draw the graph for the equation y equals 1 divided by, open bracket, x minus 1, close bracket, then we have a slightly more complicated graph. So for x equals 0, we seem to miss out the 0 there, then y equals 1 over 0, which is infinity. But if we approach from negative values of x, then that tends to a negative infinity, not a positive infinity. And it shows on the graph. So you go from -3 to -2 and so forth for x. Eventually, it starts going to minus infinity for y. But if you go from the positive side, you go from 6 to 5 to 4 to 3 to 2 and so forth. Y is starting going to positive infinity. So the equation is not defined for x equals 1. So the simple equation y equals x is defined for all real numbers. You can substitute any real number of x and you get that equation satisfied. But for the equation y equals 1 divided by x minus 1, close brackets, it's defined for all real numbers except for x equals 1. So writing an equation is not good enough. Have to write down the conditions for which the equation is valid. And so that's what I'm pointing out for these equations. Y equals x, you would state it's defined for all real numbers. And for the other equation, you would say it's defined for all real numbers except x equals 1. And you're supposed to do that in mathematics if you're being nitpicking. But I think with physicists, a lot of the time, they don't bother being precise in the statements of the math they're using. So y equals x has a condition valid for all real numbers, and the equation y equals 1 divided by open bracket 1 minus x close bracket has the condition valid for all real numbers except x equals 1. Writing equations without their condition for when they are valid is not good enough. The equations which refer to without their conditions are just vague things as far as a mathematician is concerned. And that is being nitpicking. Thus, looking at the statements of relativity's principle, the same thing applies. When don't state the conditions of when those statements are valid, then it is a vague statement. So in the case of the relativity principle, the way it's normally stated, it's just a vague statement. It's not precise enough to state what it's supposed to mean most of the time. So the example we've given is the relativity principle. The usual way it's stated is without giving any information about when it is valid. It's just a vague statement. So we now move on to the next one. It's the light speed constancy statement. It's just another vague statement. So Einstein's relativity is based upon two postulates, and those two postulates are just vague, i.e. Einstein's relativity is just vague. It's not a properly defined theory, it's just vague. AI provides us with a lot of useful information about light speed. For instance, there are different types of light speed. So AI gives the summary of light speeds, and I don't think it's giving all the different types. It's just giving a few examples of these types of light speed. So the first one is local light speed. The speed of light in a small region of space-time, typically within an inertial reference frame. It's always C in special relativity, and that's what's supposed to be meant by local light speed. Next is global light speed, the speed of light measured over large regions of space-time, which may be influenced by space-time curvature in general relativity. Next is phase speed, sometimes called particle light speed, the speed at which the individual crests of a wave travel, which can be affected by the refractive index of a medium. Next is group speed or group velocity, the speed at which the energy or information associated with a wave travels. It can be different from the phase speed in dispersive media. Next is coordinate speed of light, the speed of light as measured in a specific coordinate system, which can differ in curved spacetimes due to coordinate choices. So 1, 2, 3, 4, 5. So there's 5 different types of light speed there. And AI doesn't finish with those 5. It gives you a few more. It says retarded speed of light is the speed at which changes in an electromagnetic field propagate to an observer, accounting for the time it takes for light to travel from the source to the observer. Next is effective speed of light, the speed of light in media with unusual properties, e.g. metamaterials, where light might propagate slower than C or exhibit other exotic behavior. And this next one is an interesting one. It's superluminal speed, a phenomenon that appear to propagate faster than light, and that's light speed C, such as dispersive media or in quantum contexts, but do not allow for faster than light communication or violate causality. This is what AI is to carry on to say, each of these types of light speed is used in specific contexts, and they highlight different aspects of how light propagates through space, time, and various media. And as I said, I think there's more types of light speed than just that. So go to Wikipedia and it states the second postulate of Einstein about the speed of light being constant. It says the speed of light in vacuum is the same for all observers regardless of the motion of light, source or observer. This is known as the principle of light constancy, or the principle of light speed invariance. And that's the usual type of way the second postulate is stated. There's nothing about the different types of light speed, hence it is a vague statement. It's not telling you, presumably it's supposed to be talking about local light speed, but what about all the other types of light speed? It's not telling you, the second postulate, it's not telling you what is the relationship to those other light speeds. So the whole statement of speed of light is constant, you don't say what you mean by light speed in the context of all the different types of light speed, hence it's just a vague statement. So I know about AI, you got to be careful when using AI. It would just repeat the usual vague statements that the mainstream uses for relativity. And what you've got to do is what I do, is you've got to interrogate it. When AI gives a vague statement, I interrogate it. What precisely do you mean? And then it comes up all this things about there being different types of light speed and all that other source stuff. It tell you, there's no preferred frame. Then you interrogate it. What do you mean by saying there's no preferred frame? And then it gives you all this other gubbins about non-inertial motion and inertial motion. And in the context of those different types of motion, there can be no preferred frame, and in other contexts there can be a preferred frame, and there can, in other contexts there cannot be. So it's just vague. So thank you. That's my conclusions. What has happened with Einstein's special relativity, it's just been about giving vague statements where people can read into it whatever they want to read into it. Was if you want to think of it in terms of mathematics and have it mean precisely what it's supposed to mean in terms of mathematics, you would have to define things a lot better, but it's not. It's just vague statements. So thank you. My conclusions would be, since Einstein's relativity is just a vague theory without giving you precise information on how to define things precisely in the mathematics, it doesn't really classify as a scientific theory. It fails to stand up to being what a scientific theory should give. Thank you. That's the end. So now, hello and welcome back. So now we go in to have a look at anybody want to say anything. I can look at the comments. Hi everybody, hello, hi Kerry. Oh, Nick wants to wax waving the hand. Okay, hi Nick. Hi, hello.
Hi, I disagree a little bit with you. It certainly would say that the two principles of relativity could have been explained much better. But I don't think it was just vagueness. I think it was misinterpretation of what was actually of the stated principles. If I could, I wrote something about this before, a long time ago about the relativity principle. I'll read my comment if that's all right.
Okay. Cheers.
Okay, I may have to get out my glasses a little. Okay, I'm an adherent of the relativity principle as stated. In that regard, I contend that Lorentzian theory, which is a so-called preferred theory, preferred frame theory, based with the ether being the preferred frame, I contend that Lorentzian theory is consistent with the relativity principle. The mistake Einstein made vis-a-vis the relativity principle, as it's stated by him and in the textbooks, is that he thought that a Lorentzian theory violated the relativity principle because the ether rest frame played a singular role in Lorentzian theory. Whereas if instead of thinking in abstract math terms of phrase, Einstein had seen the physics model was that of an asymmetric clock retardation was due to velocity with respect to the ether itself. The physical interaction between two physical entities. Something that all observers could agree with as long as they became aware of how some of their observations were changed by their velocity with respect to the ether. In other words, the Lorentzian laws of physics are the same for all observer frames as long as observers are aware of all of the relevant physics laws, including those that affect his observations as a function of velocity with the ether. So I look at more as Einstein made a flagrant error in interpreting the relativity principle. And the relativity principle actually holds as long as your focus is not math and abstract constructs like frames of reference, but if your focus is on what's happening physically in terms of the interaction of physical entities, then the relativity principle is fine. It's just that all observer frames have to refer to the interaction between their velocity with respect to a physical entity, namely the ether.
Yeah.
So that's a different view. And then another point, though, is that Einstein made that I think is relevant to your comments is he was looking at velocity effects. So I think to make things simpler, he focused on inertial frames.
Yeah.
Which was a mistake. That made things simpler for him because that meant there were no forces other than, no forces, no physical effects other than the velocity effect he was focusing on. But there is no, in terms of time dilation and length contraction, there is no, the inertial frames provide no, they're not a special set of frames. Like in a particle accelerator, and you're looking at time dilation, it's always instantaneous velocity. Whether the particle is accelerating or moving at constant velocity. So I think that second thing, if you realize that second thing, then you don't have to go into as much detail as to whether you're talking about inertial frames or non-inertial frames. That if you concentrate on the physics rather than the abstract constructs like frames, then things become a whole lot simpler. And I would say the same thing for the constancy of the speed of light. Obviously, we're talking about, you have to be, clear that you're talking about in a vacuum if you're talking about the speed of light at sea. But the preferred frame is clearly the medium that the light is actually traveling through. And if you and if you understand that physics point, then you don't have to go through a lot of elaborate.
Well, you got a lot of people who believe in relativity, and they say there's no preferred frame. So the first thing is there's a conflict in how people are interpreting the principle of relativity.
Yes.
You highlighted it between Lorentz way of interpreting it versus the Einstein way of interpreting it, and the general way that the relativity is stated. It is a vague statement and it's open to interpretation.
But I think the original intent of what it should mean is correct, because the canonical form of physics laws really is the same, independent upon your observation, as long as you have an accurate picture of the physics that's going on. And unfortunately, Einstein made the big mistake of thinking that the relativity principle meant that there was no preferred frame, and by extension, no preferred physical entity like the ether, which is clearly bad physics, and that's pervaded. Just one more thing about the constancy of the speed of light. I think it's stated that principle is correct, because all it says is that the speed of light is independent of the motion of the source, which experiment seems to have shown is correct.
Yeah, but as
in Wikipedia's statement, they threw in, and it is independent of the observer, which is a mistaken interpretation of what was originally meant by that principle.
Yeah, but they're not talking about all the other different types of light speed. You just haven't.
That's another. Yeah, that definitely is another degree of complexity. But if you were talking about, the speed of light with respect to the medium,
they don't talk it that way.
Then you'd have to be clear about if the medium changes. There are other changes. There are physics changes.
The way it's usually stated, there's nothing about a medium, and the way they interpret the principle relativity, they usually interpret it to mean no preferred frame. But precisely, what do they mean by preferred frame in the context of inertial versus non-inertial motion? Then they leave that vague, so people can just read the vague statements for the two postulates, and they can interpret it in different ways, because they're not precisely defined statements.
Right.
Okay. Thank you.
Thank you, Roger.
Cheers. Thank you. Okay. Bye. Okay. Thank you. Cheers. Okay. Any other victims? No more hands up in the green room. So let's get back into the other things. So yes. So this is a question: how did you find preferred frame? Well, Spook was defining the preferred frame as being cosmic microwave background radiation, but in any physical situation, you can decide which frame you think is going to be the preferred frame. Say, for instance, you had a load of inertial frames. So you had 3 inertial frames, and you had retract that. Say you had 3 non-inertial frames, and you had 1 inertial frame. And say in that physical situation, you might decide, well, I'm going to choose the inertial frame. That's going to be the preferred frame. And why would you do that? Because the mathematics would be simpler to handle. So in any physical situation, you're looking for how to do maths simpler. So you're choosing a frame where you think the mathematics will be simpler, and that then makes it your preferred frame. And in the case of Spook, he's going to make his mathematics simpler by dealing with the cosmic microwave background as the preferred frame. But in any physical situation, you can choose different frames for what you want to be a preferred frame. Next. Yeah. So observers can be in any frame if you're dealing with thought experiments. So you are considering what would the observations be from any certain frame. Yeah. Couldn't you choose any frames preferred? Yeah. Yes, that's right. So you choose any frame for any physical situation. Let's see. Yeah, that's what I'm pointing out there. Or Jochen points out there are many different interpretations of the two postulates, and that's what I'm pointing out. The two postulates that Einstein gave are vague, and when it's stated in textbooks and so forth, it's stated in the usual vague way. And so I interrogated AI as to precisely what that's supposed to mean, and it came up with this different thing about there is a preferred frame in certain contexts, in other contexts there isn't. But if you just initially talk to AI, it will give the usual vague statements back. Yeah. You just agree with the first postulate if it's defined as Galileo's original principle of relativity. So I don't know whether it would be defined that way. Yeah. The amounts of light speed is depending on what type of light speed you're talking about and in what context of inertial or non-inertial motion. What we got down. Don't see much here of relevance. One of the comments is pointing out there are different versions of ether, and I haven't really gone into the ether issue. So, for many years, I've heard that the Michelson-Morley experiment, which is abbreviated as MNX, was the only proof of the invariance of light speed c. And so he says only recently I did read of more convincing experiments. Most experiments are based upon variations of the Michelson-Morley experiment, and actually there's an issue with that is called underdetermination. And most of the time physicists ignore underdetermination, and underdetermination means that any experiment can be interpreted by different theories. So if you've got a theory of variance of light speed c, well, maybe you can interpret an experiment by that, but maybe you can interpret it by another theory. So they don't, when they talk about the physicists talk about these experiments, they don't address the issue of why should you interpret it by a certain theory and not by other theories. And then I've also pointed out that what do you mean by light speed, and that ends up as vague and ambiguous because there's lots of different types of light speed. Yeah, so I think that covers it up, covers the issues. So talking about, so he's talking about Kelly's paper, and I wasn't talking about that, but according to Kelly, this Huffel and Keating experiment was fabricated. The result from that experiment was bodged to fit in with Einstein's relativity, but I haven't gone into that issue. So it's a diversion. Okay. So we're saying here, this is about Galileo's relativity principle, and we talked about boats and Galileo's boat experiments. And I think there's thought experiments as well, because I don't think he actually did that experiment with the boats. Better understood as demonstration of inertia. They proved argument of geocentricity, as people would believe the Earth center theory was wrong. That if Earth is moving, we should see an effect in falling object. You put the word "and" when we meant "and" an. So basically, if you go back to this big issue of the Copernican revolution, it's partly based upon relativity. You've got the initial idea of people believing the Earth was the center of the universe, the sun, planets, and stars moved around the Earth. And later on, with Galileo's experiments and other experiments and so forth, you came to this idea that, not forgetting Galileo's astronomical observations, you came at this idea that the sun might be the center of motion, but what you've got is motion relative to different things. You've got motion relative to the sun, you've got motion relative to the Earth, you've got motion relative to the other planets. So you're talking about motion being relative to things. And in that context, I think you would talk about what frame would you take as a preferred frame to make the mathematics simpler. So you've got relativity, and you've still got this context of trying to make the math simpler by choosing a preferred frame. But with Einstein coming along, it confused the whole issue. He starts his relativity theory in 1905, special relativity, where it became called special relativity. Then he extended it further to general relativity, and this relativity issue just became a confusing mess. And the mess is the relativity principle is a vague statement when it comes from Einstein. And also what is supposed to be meant by the speed of light, as I pointed out, is vague as well. So Einstein's relativity is just all based on these vague statements, which people interpret in different ways. And as I pointed out, Spook is interpreting the relativity principle as meaning there is a preferred frame, and he acknowledges that other people are not interpreting that way. So that's the problem with these vague statements. People end up believing different things from them. So I think I've covered most of the things dealt with in the comments now. So nobody's put their hand up, so I can show a video. So I got a video I can show as well. So let's see if I can call that up. First of all, that's good. So I'll be calling up a video. Just give me a few minutes. Share screen. So I'll get in a minute. I'll just give me a few minutes so I get the video. Stop. Starting. Yeah. Gotta stand up. So I'll see my entire screen. Right. Hello. There we go. I'll call up the relevant one. That one. Move that. Right, hopefully hear me. Hopefully hear me. So StreamYard didn't like that. It kicked me out and I had to come back in again. Hopefully I'm in the right place. So much for that idea of showing the video. Oh, Nick's putting his hand up again. Hello, Nick. Okay. I'm still working. Yeah. Hello, Nick.
Yes, I had a quick comment about Ion's question. He said, how do you define the preferred frame? Well, that's the wrong question. That shows a deep misunderstanding. Step one is to go from saying there's no such thing as a preferred frame. Step one is to understand there are preferred frames, but even that is too abstract math. The second step, which brings you into physics, is instead of talking about frames, talk about the interaction between physical entities. So let me just read my comment since it may not be accessible to question on. You don't define the preferred frame. You need to focus on the physics of the phenomenon you're focusing on and think in terms of the physical interactions between physical entities. For example, number one, light and the medium that it's traveling through, or for another phenomenon, the clock and the medium it's traveling through that affects its clock rate. So I just wanted to make that quick point while we were transitioning.
Hello. So StreamYard doesn't like me. It kicked me out again. So I've had to log back in again. Dear. Other occasions it doesn't want to give me a decent volume. This time it's going to be intermittent with kicking me in and out. Can't win. StreamYard gremlin doesn't like me. Hello, Nick. Are you back yet?
Yes, I already made my point.
I missed all that.
Yeah,
I missed all that.
It's in the comments anyway.
Okay, thank you. Yeah, the preferred frame is another issue to start talking about. The first major problem with it is many people who believe in relativity don't even believe in such a thing could exist. Whilst people like Spook and some others, they will accept that the idea, the concept is possible. And it's all because of these vague way that they talk about it, and the vague way they talk about it is the way they teach it. So all these vague things are said to physics students, and they grow up believing all this nonsense about relativity, which is all based on things being said wrong. So thank you, Nick. I can't see you, so I'll put you back down.
Yep.
Your video's gone. And I can't see you in the green room either. What's going on there? Oh, you're there. You're there and talking there, but no sound. Yeah. So the gremlin is at it again. Okay. Okay. So thank you. So I've made my point that AI can be used for trying to make sense of these vague statements that the people who believe in relativity give. And if you like, can end the session here. Okay. So thank you, everybody. I'll close down now, if you like. Thank you. Oh, look at how cups of tea coming now. Thank you. So most important, I stop now for my tea break. So Jerry's turning up in the green room. When there's too many people in the green room, things start playing up. So the green room is I've on here StreamYard as a host, and other people can come in as guests, but if there's too many people as guests, then StreamYard's not able to handle it. So that's another problem with StreamYard. So nobody's putting their hand up, so I think I'm safe. I think I've covered everything. So I say goodbye then. Okay. Oh, Jerry's putting his hand up. Okay. I'm going to wave goodbye. Okay. Okay, Jerry. Okay. Thank you. I've got tea.
I just wanted to join because
you got sound bad again. You still on your old computer?
I actually don't have the topic at the time.
And you got the distortion as well.
Yeah.
You haven't bought a new computer, have you?
Yeah, well, it works fine on Zoom, so I don't know.
Yeah, I know, but there's a StreamYard, isn't it? It's a StreamYard.
Yeah.
I find Zoom works all right for me, but it's other thing else messes me around. And also need headphones, I think, as well.
Because it sounds very jumbled.
I can hear you. You've got a bit of distortion in that.
Well,
you need a new computer. I mean, your computer can handle. Your computer would handle more memory. Your bandwidth is bad. Sorry, Jerry. Sorry.
Well, I guess I'll sign out. I really wanted to discuss things. Sorry. Thanks again, Roger. Appreciate the show.
Hello, so I'm back again. StreamYard kicked me out. This gremlin is decided to play me up by kicking me out of StreamYard whenever it can. So I think I can. Oh, Harry wants to talk now, and things are not safe. The gremlin can strike again. Hello, Harry. Hello. Yeah, I can hear you. Can you hear me? Not for me. You just, I could hear him, but it was distorted. Yeah. So the StreamYard gremlin has kicked me out again, and I've come back on again. So it's very irritating. So I'm just going to end things here. Thank you, everybody. Goodbye. Sorry for not being able to go on any longer. Goodbye. Goodbye. Let's see.